Hi, good morning everyone. Let's get started with the next topic, which is on table buffering in SAP. Okay, so basically SAP uses several buffers that are local to the application server and hold primarily runtime data. The R3 repository buffers, the table buffers, the program buffers, R3 GUI buffer, R3 role and paging buffer, R3 calendar buffer. So we will go through in details into the system. We'll log into the system and see where to see these particular buffers and what information is stored in them. Okay, here in this particular pictorial diagram, here you can see that this is a user which is using GUI to connect to app server 1, and this user is trying to connect to app server B. Okay, this has the R3 buffers. This also has its own R3 buffer. Okay, this is a communication system, and here you can see that at this layer we have database management system. This is DBMS process. This is the database cache, and this is your database. Okay, so let's go to the next slide where we are showing the details. Say for example, by specifying that a table is to be buffered, you can reduce database accesses and thus improve performance. So that is the main objective. So you need to take note that when you do buffering, when you buffer a table, you are not going to database to access that. So eventually means once it is buffered, everything will be given from the buffer, so it reduces the IO which is taking place. So that is pretty important, size of the table buffer. Okay, so why we use table buffers in R3? The difference in the time required for local R3 buffer access and that required for database access is significant and affects database server load, dispatch time for R3 dialog steps. Okay, so here you can see in this particular slide, here you can see that in case if we are getting the data from the table buffer, you are taking about 0.2 to about 6 millisecond, but if you are going to the database to get those records, you are taking about 8 to 600 millisecond. So here you can see the drastic difference when you get the record from the buffer over you get the record from the database. So that is the key difference that need to take note, and that is the one reason why we use table buffers in R3. Okay, table buffer types. Basically there are three types of table buffering. One is the full buffering, that is 100% of a table's content is loaded into the buffer on the first access to any data from the table. Okay, so that is the first type, that is everything is buffered whenever the first access to any data from the table happens. Next is generic buffering, that is two key fields are buffered. So generic buffering, basically a number of generic key fields you can specify, say first or n number of key fields is specified and only those key fields are buffered. A typical case of generic buffering is client dependent buffering, where the client name is the key field. If you specify resident buffering for a client dependent table, the ABAP dictionary automatically uses generic buffering with one key field, that is single record buffering. So all three table buffering types can be seen as special variants of generic buffering. For full buffering, n is 0. For generic buffering, n is less than between all key fields, between 0 to all key fields, and for single record buffering, n is equal to all key fields. So that is about the table buffering types. Then buffer synchronization. So two things happen when a buffer table is updated. Okay, so you need to take note that whenever any update is happening to this particular table, okay, so this data, if it is given from the table buffer, it will be outdated. Okay, so the update is executed on the database table. The buffer of the local R3 instance on application server A is either updated or the contents are marked as invalid and reloaded on the next access. So this is the key thing. Basically, whenever any update is happening for this table which is already buffered, So what will happen is that this database, either it will mark this content as invalid, and whenever the next write happens, or whenever someone requested something else to read it, it will be given from this particular given from the database, thereby updating this buffer. Okay, then next is this example. Basically what we are showing here is we are showing a landscape consisting of more than one instance. Okay, so here you can see the two, one is app server A and another is app server B. The buffer of the non-local R3 instance is not updated immediately. Okay, so this is buffer is not up to date because we are accessing local buffer. This is up to date. The updating statement is executed by the R3 database interface dbif, which inserts a record into the table dd log indicating the change to, for example, table T001. There are two profile parameters, basically the buffer mode rdisp/buffer mode, and possible values for this parameter are send off, send exec, auto, used for central system. Okay, for distributed system, you have rdisp/buffer time. Okay, so let's go to the next slide, where basically you have buffer synchronization occurring every 1 to 2 minutes. Local buffer is up to date, buffer is invalidated. So granularity of invalidation, fully buffered tables, any changes invalidate the entire table. Generic buffer tables, changes in work area mode invalidate data with the same generic key field. Single record buffer table, changes in work area mode invalidates one buffered record. Okay, so setting the buffering for a table. How do we set it up? We can go to the transaction called SE13 and set up the buffering. You can say whether it should have no buffering, full buffering, generic buffering, or single record buffering. Okay, there are some ways where you can bypass the buffering. Basically, you can use this syntax just to bypass the buffering. You can use any of the syntax: select bypassing buffer, select for update, select distinct, select clause contains is null. So basically these are the different ways you can bypass the buffer. Okay, so bypassing partial buffering, it's an example, just you can go through it. Okay, now buffering strategy, that is technical criteria. You can buffer R3 tables that are relatively small, normally less than 1 MB. Okay, infrequently changed, for example, changes is less than 1% of read. Not immediately required to be consistent in all applications, server buffer and accessed by primary key. Note, only buffer tables greater than 10 MB in special cases. Buffers searched by secondary index are not possible. When buffering new table, ensure that the table buffers are large enough. Okay, then for the application, so here we saw the technical criteria, now application criteria. Main thing is transaction data is never buffered. For example, accounting documents in table BKPF, sales document in VBUK. The reason these tables are too large or too often changed, master data is normally not buffered. Examples: customer master in table KNA1, material master in MARA. So reason these tables are normally too large and are often accessed by secondary indexes. Okay, tables like T001, exchange rate table, TCURR. Reason these tables are relatively small or rarely used. Okay, then on the condition table, basically condition tables, they include tables for pricing, for material, for text determination and partner determination. Okay, from 000 to 499 indicates that the table is part of a SAP standard and is buffered as delivered. from 500 to 999 indicates that the table is customer created and is not buffered. You should check whether the table is or should be buffered or not. Next is the buffer optimization. So there are a couple of techniques where you can find out what should be buffered, what should not be buffered, and this particular monitoring tab, it will give you some idea about the buffering. Okay, this roadmap shows you how to lead you to find problems with table buffering. So we need to go to ST03 for task type dialog and update. For both respective tasks, choose transaction profile and sort according to the response time. Okay, so we will go there and let's look into that. Okay, so this is an example of ST10, and this is basically its analysis roadmap using table call statistics. So this roadmap helps you to decide which table should be buffered. Then monitoring table buffering. To detect incorrectly buffered tables, we use transaction ST10, or we can use the SQL trace, that is ST05. To determine the rate of table change, basically look at field changes, ask the developer or user. To determine table size, for tables which are already buffered, see table called statistics. For tables which are not buffered, use analysis of table according to index DB05. Okay, so let's go to these systems. Okay, so let me take you to one of the system and show you these fields. Okay, so let's connect to say ST03. Okay, in ST03 the system is getting into ST03. Give us a few seconds. Okay, basically this is the upgrade is running in this system, so we are getting this, that you cannot perform any other activity. Okay, so let's go to the another system. Okay, so here we are running ST03. Basically it will show you the data, and let me open one more window in the meantime. So basically here you are seeing this is the workload monitor. So in the workload monitor, you can see this is the view of workload monitor that I wanted to show you guys. Okay, so let's go to the next one, which is detailed analysis. Okay, so here this will give you an idea about the usage. Say for example BI workload, depending on the type, collector and performance DB. Okay, then you have, if I expand this, you will see performance database. Okay, monitor database, workload database. So these are the different things which is captured. Okay, so let me double click on this particular workload. Okay, it's coming, it is taking some time. So here you can see that this is showing the detailed workload overview, where you have the task name, the number of steps, the time it takes to complete a particular step, average time to process a step, average time it has spent on CPU, time spent on database, the wait time, the roll in time, the roll wait time, the load generation time. Okay, so basically it shows the different breakup of the response time. Okay, so let's go into the transaction profile. So transaction profile, if I select the standard profile over here, standard profile, what you are seeing is you are seeing the different times. This is basically the database part. Okay, so this particular tab shows you this report run with this particular background job, how many read happened, and basically it is showing you the transaction details. Okay, so next thing is, let's see, we have seen this. Let's review the workload overview. Okay, workload overview. On the similar line, we have this breakup of the response time. We can go to the database. Okay, so here you have one tab for database, that is the DB access. Okay, then we have role information. Then we have basically the parts of the response time, and the total, all the data is captured here. So basically what I'm trying to show is, in this particular transaction, there are two options. One is expert mode, okay, and service engineer. So if I go to the expert mode, this is what you will see. If I go to the service engineer tab, okay, so basically the respective roles are, these are the only roles that is there for this user. Okay, so that's all in this thing. Let's go to the another T code, which is basically ST10. So let me open another window for that. Say for example, if I want to go to ST10 from here, I need to type /n ST10. Okay, and just press enter. Okay, now here in this is showing the table call statistics. Okay, so it will show you the statistics of all tables, not buffer table, single key buffer table, generic key buffer table. Okay, so not buffer table, basically just we want to see which tables are not buffer. So just click on show statistics, and it will show you the table list which is not buffered. Okay, so this list, this is a big list. What is the percent of changes taking place? What are the number of direct reads, sequential reads, changes, and the database activity on these tables. So this table will give you an overall idea about which tables are buffered, which tables should be buffered, and what are the changes taking place on a particular table. In case if you are deciding for which table I should buffer and which table I should not. Okay, so that is about the buffering part. So we have covered these things. Okay, so we have covered. Okay, let's see these buffers. So let me go to the respective T code to show you these buffers, how they look like. Okay, so here we have seen these things. Okay, to go back, we can just press this back arrow. Okay, now let me go to this particular T code. Basically, I just want to go to this T code, which is ST02. It's taking some time for refreshing. So I just want to show you the different buffers which are available. Say name buffer, PXA buffer, CUA buffer, name tab buffer. Okay, so let's go through them in detail. Okay, here you can see the different buffers that we were talking about. We are in the T code ST02. Okay, you can see the name tab buffer, end tab, table definition, the field definition, the short name tab, initial records. You have program, CUA, screens, calendar. Okay, then tables, export, import. Okay, this is one of the key field here, that is swap. Okay, if you see there is a lot of swap happening over a period of time, that indicates that you are running low on memory. So that is one key thing to note of. Okay, so let's go down. You can see the role area. Okay, you can see the role area, the extended memory, the heap memory. Okay, then call statistics, select, insert, how many select and insert and update operations are taking place. Okay, so it is giving you an overview about the buffers, the memory, the call statistics. So this is one pretty decent transaction to give you an overview about the statistics, basically the buffers, the table buffers. Okay, in case if you want to see the detail analysis value, just click on this tab, which will show you the detail analysis value. You can click on, say, table definitions. Okay, so table buffers, these are the types that we just saw. Okay, other buffers, we can go to the other buffers as well. Memory utilization is seen here. So if I just click on, say, table definition or generic key, tables which are buffered on the generic key. Okay, so you can see that these are the tables which are buffered on the generic key. Okay, that's all actually I wanted to cover in this particular session. Thank you for joining and have a nice day.